Hello everyone. In the last video, I mentioned that I wanted to do a video about these little bushings. Before I get into that, I'd like to talk about the design of the fixture real quick, because it goes into what bushings I chose to use. I wanted it to be about an inch thick, and all I really needed it to do was clamp and release a bottle cap on and off of these dowel pins that I have stuck into the top. Being a pneumatic cylinder, it obviously needs a piston, and the piston clearly needs to have some rigidity to it, because if it was wafer thin, it just kind of flex around inside the cylinder or whatever. I made this at about 10 millimeters thick. So if you're starting with an inch or 25 millimeters, and you need 5 millimeters of travel, and you're using a 10 millimeter piston, you're obviously left with 10 millimeters of thickness to the actual, ceiling or top of the fixture. Inside that 10 millimeters, you have to put your O-ring, your bushing, and this little ledge on the top here that holds the O-ring and the bushing in there, prevents them from coming out with everything else. I don't know exactly how thick this would have to be. It's aluminum, so it's not that strong, but it's probably not that much force going against there either. I basically picked a number out of thin air and picked 2 millimeters for that thickness. That obviously left me with 8 millimeters for the bushing and O-ring. 8 millimeters is pretty close to 5/16 of an inch. So that's basically what I was working with. The shafts I chose, I wanted to have 2 shafts in there, and I didn't want them to be too big in diameter, because the more space you're dedicating to the shafts, the less area that remains for the piston. And obviously the larger the area of the piston, the more force can be put onto it from the air pressure inside there. So I chose 3/8 of an inch for the shaft diameter. My first task was to find an O-ring that was both thin and had a inner diameter of 3/8 of an inch. And as I mentioned in the last video, I chose this O-ring, which has a width of 1/16 of an inch. 5/16 minus 1/16 is 4/16, aka a quarter of an inch. So I needed to find some bushings that were 3/8 of an inch inner diameter and a 1/4 inch long. And I came up with these, and they, of course, have a wall thickness that's similar to the O-ring, which is about 1/16 of an inch as well. They come in this little package here. So I'll just kind of cut to the chase here. If I had looked at this package a little more closely, or if I'd looked at the McMaster car site more closely, I would have noticed that these bushings are 502 thousandths to 503 thousandths outer diameter. The reason I mention this is I was basically assuming that they were exactly 1/2 an inch in diameter. So the first time I milled this prototype, I made this hole 1/2 an inch in diameter. Well, the thing is if you have a hole that's exactly 1/2 an inch in diameter, like these 2 holes in this vice jaw that I have, you can actually tap one of the bushings into those holes. So, it appeared to me that it was sized correctly. Well, I took my shaft and tried to put it into, put it through the bushing, and it wouldn't go. Not easily, at least. Normally, they would just, slide in there, no problem. So my first instinct was to, grab the rubber mallet again and tap the shaft into the bushing. Well, it went in, but it got stuck in there. And I had to basically just, tap it out from the other side. Not too big of a deal. The bushing, on the other hand, got stuck in there, and I had, almost no way of getting it out. What I came up with, though, is to use a tap that's slightly smaller than the bushing and tap it into there. And being brass, it was real easy. And this one I've already done, so it's, you can just able to do it with my fingers here. But tap it in, give yourself like a little fulcrum here, and then grab it with some vice grips and pry it off of there. And that works pretty good. This hole, being a blind hole, you can also continue to screw this tap in, and it'll lift the bushing out of there. So I am trying to rush through this. So like I said, if I had just noticed that this, they actually tell you how big it is, or if I had taken the time to simply measure them, I would have seen that they're not exactly half an inch in diameter. And I would have got through this quicker. Hopefully, if you guys don't know how to read like me, watching this video will let you avoid this problem as well. Unfortunately, when I came into the problem myself, I just kept increasing the size of this hole by between 0.005 and 0.015. What I ended up doing is I got up to 502.5 thousandths and put a bushing in there again, and it was still too tight. At that point, I was getting, I was losing patience. So I was like, fuck it, I'm just going up to 504 thousandths. That's got to be big enough. Well, it is big enough, and it is, in fact, too big. So, the O-ring goes in there fine. And the bushing basically just slides in if you don't have a camera in front of you. Then my shaft goes through there. No big deal. There is a problem, though, of course, is that bushing, there's, virtually nothing holding it in there. And when the piston moves in the opposite direction, it'll slide out. Thankfully for this application, there's only 5 millimeters of travel, so the bushing doesn't actually have an opportunity to come out all the way. Since this bushing is 1/4 of an inch, aka 6.35 millimeters, which is obviously greater than the 5 millimeters of travel that this air cylinder can do. So what I tried to do here is I took some thread locker and put it in both the holes here. And it seemed to work pretty good for a while, but as you can see, this bushing has come out, and I can't even tell that it was glued in there. I assume maybe this one might come out real easily too if I, give it any kind of prodding. So through trial and error, and eventually reading the bag and the website and actually measuring them myself, I found that bushing holes of 502.5 thousandths were too tight, and 504 thousandths were too loose. So for the final fixture plate, what I've decided to do is 503 thousandths. And I've actually already milled that, and I have it underneath here. And there it is. I actually milled this about a week ago, but I've been trying to get these videos caught up to somewhere near where I am with the milling before, continuing with the rest of the project too much. So I'm not going to dwell on this too much and get back to the bushings. It looks like 503 thousandths was a good choice, as I have placed one whole bushing in there, and it went in pretty good, and the little shaft goes through without a problem. I don't know where to put it. So what I thought I'd do is put the rest of the bushings in there and play it at the end of this video like in fast forward.